Hello, I'm Bioe from Grade 9 and I want to introduce you to rad fusion. Current models for thoracic disease detection report OGS from zero point 0.7 to 0.84. Three fundamental technical barriers come into play. First, modality dependence. Multimodal models degrade catastrophically when any modality of data is removed at inference. Emergency departments don't have access to quality data all the time. Second is interpretability. Methods like GRAD can produce coarse attention maps that highlight edges and caveats, but not disease regions, which decrease the amount of trust that the patient or the doctor has on the AI model. Third is class imbalance. Rare pathologies like hernia at 0.2% are often not detected in classical models. Rad fusion improves upon the previous state of the art by a massive 7%, and according to the math, that's about 250,000 lives saved every single year. It was trained on 112,000 images and clinical narratives with patient level splitting to avoid data leakage. Here you can see how rad fusion focuses on the specific localized area where it is seeing the condition. This makes it a lot more credible and trustworthy than the previous state-of-the-art models. Several novel components has been introduced to the traditional architecture to improve its performance and to make it more trustworthy and interpretable. Here we have a small demo of the application. Here the chest X-ray is uploaded as a file to the AI model, which assesses the probability of different diseases, and it compares it with the patient history and uses an LLM along with the transformer that we explained to diagnose diseases effectively. I'm going to show you how this actually works. First of all, I am going to take up a sample X-ray image and I'm just going to hit on analyze. Here in just a few seconds we have all the probabilities that correspond to different diseases. Here no finding has the highest probability, which in this particular case is also the accurate ground truth. Also, we produce a heat map. This is the most critical part of the project, as this highlights which areas of the X-ray the model is focusing on. This ensures trust between the doctor, the model, and the patient. Now let's move on to the report that the model has generated. Here we can see an LLM generated report that explains the different factors that play into the disease prediction and the probabilistic progression of the disease with comorbidity cases. With this thought process, which is the main leverage of our model, the thought process of the model is necessary to have, as it again builds more trust between the physician, the patient, and the model. We prioritize explainable AI so that it gains trust of the patients and it can be implemented in hospitals at a large scale. So that was about it for rad fusion.